In this video, we're going to be given information and asked to find the equation for a parabola. Remember that parabolas can open 4 different directions, and those directions are up, down, right, and left. In the up and down ones, our equation is going to be y equals a times x minus h squared plus k. And if the a value is positive, the function is going to open upwards. If the a value is negative or less than 0, the function is going to open downwards. In the left and right parabolas, the vertex form is x equals a times y minus k squared plus h. If a is greater than 0 or positive, the function is going to open to the right, and if a is less than 0 or negative, it will open to the left. And there's another video on that if you want to watch it. Now, the other thing to keep in mind is that the vertex in either situation is going to be h, k. Also remember that inside the parentheses is going to be the opposite of what it looks like. So here it's negative k, but in our value it's positive k. So the vertex is always going to be hk. So the k value is with the y, and the h value is with the x. In this situation, the outside parts and the inside parts, same thing here. Y is outside with the k, and the h is inside with the x. And the other thing to remember is that when we have any parabola, whether it opens up, down, left, or right, there's a point inside of the parabola that we call the focus, and there's a line outside of the parabola that we call the directrix. And the parabola in green here is all of the points that are equidistant from each of those. We also have this point, the vertex, which is exactly halfway in between them if we were to draw a perpendicular line to the directrix here. The distance from the vertex to the directrix and from the vertex to the focus is always going to be the same. We call that p, and the variable p stands for focal length. So let's try some problems with this. In number 21, I'm given that the vertex is at 0, 0, and that the focus is at -2, 0. So the first thing I like to do is graph those 2 points and then decide which way my parabola has to open. In this case, the parabola is going to have to open to the left so that the focus can be inside of the parabola. Now, as you'll recall, if the parabola opens to the left, we're going to have an x equals equation in this form, and the a value is going to be negative. So I'm going to have x equals -a times y minus k squared plus h. Now remember, hk is our vertex. And so since they're both 0, I can substitute 0 in for k and for h, and this is what my equation looks like. Now you all know that if I subtract 0 from something or add it to something, all I have left is what I started with. So I don't really have to put the plus zeros in there. So now all I have to do is figure out what a is. Well, there's a formula for figuring out what a is. A is equal to 1 divided by 4 times p. And as we discussed, the p value is the distance from the focus to the vertex or from the vertex to the directrix. I don't have a directrix here, so I'm going to use the focus to vertex length, and that is 2. So I'm going to substitute a 2 where the p is, and I'll see that a is 1/8. Now don't forget the negative sign that was there because it opened to the left, and I have this equation. Now I don't have to have the parentheses there, so if you don't want them there, You can take those away, but I do have to have the y squared. So, this is my equation for this parabola. Now here's another one. We're going to start it off the same way we did the last one. We're going to graph the vertex and the focus. And we're going to draw in our parabola the focus. So the parabola opens downwards. Alright, if it opens downwards, then it's going to have to be a y equals equation. So we're going to have a negative a, because that's where the negative y values are, times x minus h squared plus k. H is the x part of the vertex, and k is the y part of the vertex. So I can substitute in zeros for both of those. But like we saw in the last problem, we really don't have to worry too much about zeros, because adding and subtracting 0 to things doesn't really change the values. So I don't have to write either of these here. Don't need that plus either. And I could get rid of the parentheses and just write x squared if I wanted to. Alright, so now I just have to figure out what a is. And to find a, I use a formula involving the focal length, or p, which is 3 in this problem, the distance from the vertex to the focus. So 3 is equal to 1 over 4 times a, or I could write a equals 1 over 4 times 3. And you'll notice that this is the easier formula to use, a equals 1/12. But if you cross multiply in this one, you get 1 equals 12a, and then you'll divide by 12 on both sides to get the same thing we got this way. So I'm going to replace the a in this equation with the 1/12, and I'm done with this problem. Alright, for the next one, this time we're given the directrix. So I'm going to graph these just like I have the others. The vertex is still at 0, 0 in this problem, and the directrix is x equals 6. Remember, x equals problems are vertical lines. 1, 2, 3, 4, 5, 6. So we're going to have a vertical line through 6 on my x-axis. Now remember, a parabola never crosses its directrix, so this parabola is going to have to open over here to the left. So if it opens to the left, it's going to have to be an x equals, and it's going to have a negative a, because the negative x values are to the left here. So negative a times y minus k squared plus h. Remember, your vertex is hk. So the k goes with the y part, and the h is with the x part out here. And again, since they're both 0, I don't need this, and I don't need this. And you can go back and watch the last two if you need to see that again. So I can just write negative a times y squared if I want to. But I still have to know what a is, and to know what a is, I can use a formula involving p. P is the distance from the vertex to the directrix, and in this case that is 6 units. So P is 6, and I know that A is equal to 1 divided by 4 times P. So A is 1/24, and I can replace that in this problem like that. So this is my equation in number 29. Now in number 33 they give you the focus and the directrix but no vertex. We're going to start it off just like we have all the other problems and graph 0, 1, 2, 3, 4, 5, 6, 7, 8. So it didn't quite fit there. So this is my focus way up here, and the directrix is in this problem a horizontal line. 1, 2, 3, 4, 5, 6, 7, 8 through y equals -8. So the vertex is equidistant from the vertex and the focus. So I need this distance to be cut in half. And if you were to count this, you'd probably notice really quickly that's going to be 16. Well, half of 16 is 8, so I'm going to go up 8 from here, down 8 from here, and right in the middle, that's going to be my vertex. So my vertex, once again, is 0, 0. And this parabola is going to open up so that the focus is inside and the directrix is outside. If it opens up, it's going to have to be a y equals, and it's going to have a positive a value. So x minus h will go inside, and the plus k, the y part, will go outside. So my vertex is h comma k. We've seen several times that when you substitute zeros in here, you don't really need to write them. So I can just do a times x squared and figure out what a is. So since p is part of the formula to find a, and p is the focal length, that's the distance from the vertex to the directrix, which is 8, or from the vertex to the focus, which is also 8. You can use either of those 8s and say a equals 1 over 4 times p, which is 8. So I get 1 over 32 for a. And I'm going to substitute that into my equation, and I'm done with this problem.